Whether it's 15, 20, or 30 years from now, there's no doubt that our destiny will eventually lead us to Mars. We'll get familiar with the moon first, and then we'll take the big leap. In this exploration, the most challenging one humanity will face, there will be no room for even the slightest mistake. There will be no one to help our astronauts. They'll have to do everything on their own, relying solely on their skills and the resources on board to handle the inevitable emergencies. The members of the first crew to attempt this feat are probably already among us, perhaps very young and still unaware. So if you have children of any age at home, watch this spectacular video with them. You might inspire some kids who are still uncertain about their future to one day choose the path that will lead them to set foot on the most extraordinarily exciting world silently moving in our minds. Mars is the red planet, red like blood, a fitting color for the god of war it's named after. In the sky, the planet is easily recognizable. Nothing shines with that color and brightness except for the star Antares, whose name fittingly means rival of Mars. Of all the planets in the solar system, Mars is the most similar to Earth. It's significantly smaller with a diameter half that of Earth. It's also much colder and drier, but 4.6 billion years ago, it was like Earth, warm and wet, with a thick atmosphere and abundant water. If humans had been around on Earth back then, they would have looked up and seen a blue planet, not a red one. Everything changed around 4 billion years ago when things took a turn for the worse. Like Venus, Mars experienced a global climate catastrophe. The reason, unknown until recently, lies in its core. It's hard to determine this just by observing the planet through a telescope, although today even telescopes used by amateur astronomers can easily show the features of the disk of Mars. Galileo was the first to observe the planet with a telescope in 1610, but the instrument was too small and the view too blurry to distinguish surface features. The first surface feature of Mars was discovered in 1659 by Dutch astronomer Christian Huygens. He saw a dark triangular mark, drew it, and described it as a large pond. At the time, it was thought that the gray spots on the moon were oceans, seas, and Huygens followed that line of thinking. In reality, both topographical features are caused by the different coloration of certain minerals and rocks compared to the rest of the surface. By tracking the repeated appearances of this triangular mark, Huygens was able to determine the rotation period of Mars, its day. A Martian day is called a sol and lasts just 37 minutes longer than Earth's 24-hour day. Mars is twice as far from the Sun as Earth, and its year is much longer, 687 Earth days compared to our 365. The tilt of its axis is similar to Earth's, 25.2 degrees, compared to our 23.5. Consequently, day and night alternate just like on Earth, and so do the seasons, but winters are much colder and last longer. The orbit of Mars changes over time, and with it, the cycle of seasons and climate. Currently, surface temperatures range from 20 degrees Celsius during the day to minus 140 degrees Celsius at night. On Earth, the coldest place is Dome Fuji, a research station on the Antarctic Plateau where temperatures drop to minus 80 or minus 90 degrees Celsius at most. In 1666, Italian-French astronomer Gian Domenico Cassini discovered that Mars has polar ice caps. Through a telescope, these appear as white spots at the planet's poles. One grows while the other shrinks, and vice versa, depending on the changing seasons. The polar caps are deposits of ice and dry ice 2 to 3 kilometers thick, with steep cliffs at the edges. The surrounding plains are also covered with dry ice, solid carbon dioxide, which sublimates with the changing seasons. Sublimation is the process where a substance transitions from a solid to a gas without passing through the liquid state. As for water ice, it usually melts and turns into liquid before becoming gas, vapor, but it sublimates if the atmospheric pressure is low, like on Mars. In spring, as the ice grip loosens, the ground on the slopes is freed and slides downhill, raising clouds of red dust. On Mars, the northern polar ice caps shrink in the warmer summer when its northern hemisphere leans towards the sun. They grow again during the colder winter when the North Pole is oriented away from the sun. The same thing happens in the south. Mars and Earth are the only planets in the solar system with polar ice caps that wax and wane with the approach of winter and summer. So, the seasons on Mars vary like those on Earth. The seasons differ in length more than they do on Earth because the orbit of Mars has greater eccentricity than Earth's. For instance, Northern Hemisphere spring lasts for 194 sols, while fall lasts for only 142 sols. But when did we start to understand that Mars could be a planet similar to Earth? In 1840, Wilhelm Beer, a German banker and amateur astronomer, created the first maps of Mars with his colleague Johann von Madler. They reproduced the dark areas that remained in fixed positions, initially described as water basins. However, the spots had variable color and intensity, and in 1860, French astronomer Emmanuel Liais suggested they were vegetation, thinking the changes were due to the seasonal cycle. It was eventually discovered that they were changes in visibility caused by dust storms. In 1877, Italian astronomer Giovanni Schiaparelli mapped the surface of Mars, classifying the dark shapes as continents, islands, and bays. He also seemed to see numerous long, straight channels connecting some landscape features. Percival Lowell, an American businessman, invested his wealth in building an observatory in Flagstaff, Arizona, to search for Pluto and study Mars. He also saw the color changes in the dark areas and linked them to the changes in the polar caps. When a cap shrank, a dark, irregular greenish-blue band formed around the edge, which then disappeared as the cap shrank further. Then, a dark wave flowed into the channels towards the equator. It was as if a large amount of water was revitalizing the vegetation, just like the seasonal floods of the Nile Valley. Lowell was not familiar with Schiaparelli's map and hoped there was life on Mars. He interpreted Schiaparelli's channels as canals, meaning artificial constructions rather than natural formations. This led him to conclude that the canals were dug by Martians to create an irrigation system and alleviate the perennial drought by channeling water from the polar caps. The belief spread that Mars was a dying, arid world, but not only that. Fueled by novels like The War of the Worlds, it became a common belief that its inhabitants intended to invade and colonize Earth. Less fancifully, in 1877, American astronomer Asaph Hall discovered two satellites orbiting Mars. The larger inner moon is Phobos, fear, and the smaller outer moon is Deimos, terror. The satellites are named after the sons of Ares, who accompanied him in battle. Like Earth's moon, they revolve around their planet in the same time it takes them to rotate, so the same side always faces Mars. In that sense, they are moons, but otherwise they are very different from our moon. Phobos skims above Mars 3 times a day at a height of about 6,000 kilometers or 3,700 miles, while Deimos takes slightly more than a day to orbit Mars at about 23,000 kilometers or 15,000 miles above it, roughly 6% of the Earth-Moon distance. No other satellites in the solar system travel so close to their primary. Undoubtedly, a mission to either would find chunks of Mars in the form of meteorites. While both are cratered, Phobos boasts a crater nearly half its width. They contain too little material for their internal gravitational attraction to shape them into round worlds. Phobos also has grooves that may be the result of tidal stretching. The mean radius of Phobos is 11 kilometers or 6.8 miles, whereas Deimos is only 6.2 kilometers or 3.9 miles. In fact, they look more like captured asteroids than the Moon. Although today Phobos and Deimos can be seen occasionally eclipsing the Sun from the Martian surface, their sizes and distances prevent them from completely covering the solar disk. They are among the tiniest satellites in the solar system. Small as they are, their situation cannot last. Phobos is literally inching towards the Martian surface and cracking up. In less than 50 million years, Mars may lose a moon but gain a ring system. This discovery further reinforced the idea that Mars was a planet quite similar to Earth. But all this ended with the new century. In 1909, at Meudon, just outside Paris, observing the planet with a large telescope, Greek-born French astronomer Eugenios Antoniadis concluded that the channel should be considered merely an optical illusion due to the human eye's tendency to interpret point light, and dark spots observed with modest magnification through the Earth's atmospheric shimmer as geometric structures. There was, therefore, no truth in imagining a Martian civilization entirely devoted to building irrigation canals for the planet. Doubts that Mars could host changing vegetation continued almost to the present day, and only with the advent of the space age did the illusion of an inhabited world finally fall. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. The first mission to visit Mars was Mariner 4, which, after nearly 8 months of flight, flew over the planet on July 15, 1965, at an altitude of only 9,846 kilometers, continuing along the circumsolar trajectory it was on. During the closest approach, it transmitted 11 images of the Martian surface for about 25 minutes, and the 7th frame showed something unexpected. The planet's surface appeared completely arid and heavily cratered. These photographs dispelled any illusions of the presence of life forms, even if only plant life. The red planet thus became for everyone the dead planet. The first spacecraft to orbit Mars, and indeed the first to orbit a planet other than Earth, was Mariner 9, which arrived on November 14, 1971. At that time, a dust storm was raging across the entire planet, hiding its surface. The scientists saw nothing but a yellowish haze, and there were long faces in the control center at such bad luck. Dust storms are a frequent phenomenon on Mars. Often, they are small tornadoes, like those on our planet known as dust devils. On Mars, dust devils roam the desert, moving at high speeds and changing direction in a way that seems both intentional and wild. They stir up the ground, revealing the dark material beneath the red surface dust. From space, this dark material looks like a scribble in the desert, traced by the dust devil on its path. Martian dust storms can be much larger than individual tornadoes. Sometimes they are so massive that they are visible from Earth. They obscure topographical features and can last for months. They lift the lighter dust, and from the surface of Mars they completely block out the sun. The winds carry the sand everywhere, covering the entire planet, including the polar ice caps, which take on a layered structure like a chocolate and cream cake. A layer of dust covers the ice, then the ice reforms and gets covered again. Dust storms occur mainly in summer when convective motions create strong winds that lift the dust. The most intense storms hit the planet's southern hemisphere. This is because when it's summer in the southern hemisphere, Mars is significantly closer to the sun than when it's summer in the northern hemisphere. Consequently, the southern summer is hotter, so the convective motions are stronger and create more powerful dust storms. Once started, the largest storms can last for weeks or months. Just like with Mariner 9, which had to wait patiently in orbit for the dust to settle, which happened too much later in mid-January of 1972. The long wait was rewarded, however. The probe revealed that the surface of Mars, contrary to what Mariner 4 had shown, which had evidently managed to photograph only a limited portion of the surface, had a certain variety. First of all, Mariner 9 identified recently formed volcanoes. The most impressive of these is Olympus Mons, standing 25 kilometers tall. Think of Everest, which at 8,848 meters is the highest mountain on Earth. Olympus Mons is nearly 3 times taller. The largest volcano on Earth by volume is Mauna Loa, which makes up most of the big island of Hawaii and rests on the Pacific Ocean floor. Well, Olympus Mons has a volume 100 times greater, and its size justifies its grand name, as in Greek mythology, Mount Olympus was the home of the gods. In the same region of Mars, the Tharsis region, there are several other volcanoes. All around, there are lava flows that look recent, perhaps only a few million years old, but no eruptions or active lava flows have ever been observed, and there doesn't seem to be any violent seismic activity either. Additionally, Mariner 9 discovered a massive tectonic rift, which was named Valles Marineris, Mariner Valley, in honor of the probe. The system stretches for 4,000 kilometers or 2,485 miles east-west along the equator, is 600 kilometers or 373 miles wide, and 7 kilometers or 4.35 miles deep. It's a complex of geological fractures 10 times longer, 7 times wider, and 7 times deeper than the Grand Canyon. It's the largest known structure of its kind in the entire solar system, extending for about a quarter of the circumference of Mars. However, Mariner 9 also showed that the most common terrain type on Mars is vast, arid plains of red or yellow, similar to the rocky deserts on Earth. A turning point in discovering many of the secrets of Mars came with the two Viking missions of 1975-1976. Each mission involved a spacecraft composed of two parts, a lander and a mother capsule that remained in orbit around the planet after releasing the lander onto the surface. The two landers were the first to touch down on Mars. Viking 1 remained operational for 6 years and Viking 2 for 3. They searched for biochemical traces but found none. The surface appeared sterile. It seems there is no life on the surface of Mars, or if there is, it doesn't have the properties tested by the landers during experiments conducted directly on the Martian surface. The big surprise came with the discovery that vast areas of Mars must have once been covered by water. The two missions demonstrated this by identifying geological structures that usually form in the presence of water. There were perfectly flat areas with enclosed basins. Evidently, this was material accumulated at the bottom of ancient lakes. The lakes had formed layers of clay. In common language, the word clay has a broad meaning, but in geology it has a technical significance that goes beyond the material's appearance. Later, those layers were studied with satellites orbiting the planet to determine their chemical composition, and it emerged that they were made up of minerals deposited by water, definitive proof that certain areas of Mars were once under still bodies of water. Other clues to the presence of water are the drop-shaped islands, elevated rock formations compared to the plains, extending downstream of obstacles like crater walls. The shores of those islands, now surrounded by arid land, look like cliffs hundreds of meters high, which must have been swept and eroded by devastating floods. Some plains also turned out to be scattered with rounded boulders, probably pushed and shaped by currents. Essentially, there was increasing evidence of abundant water on Mars in ancient times. Scientists have named this period the Noachian, inspired by Noah and the Great Flood. But where and why did all that water disappear? And more importantly, could this mean that Mars might have once hosted life? Questions that, at the time, had no answers. Starting in the 1980s, Mars exploration accelerated. Fewer launchers, but longer missions that made many more discoveries. Since 2010, there have always been 4 to 8 active vehicles on the planet and in its orbit. The ones that usually generate the most excitement among space mission enthusiasts are the rovers, which land on Mars and traverse its surface. The first ones were the size of a coffee table, while the current ones are the size of a car. The total distance they can travel has also increased from 100 meters to tens of kilometers. Communicating with Earth, the latest rovers can choose an interesting point to visit and reach it in a partially autonomous manner. This is a significant advancement because a radio signal can take up to 25 minutes to travel from Earth to Mars or vice versa, so it could take an hour from when the rover sees an obstacle to when it receives the command from Earth to go around it. The studies conducted by rovers over these decades include mapping the surface, analyzing rock composition, and investigating the atmosphere and magnetic field. Mars has a very thin atmosphere, with surface atmospheric pressure of about 0.6% of Earth's. However, it is sufficient to partially protect the surface from solar and cosmic radiation, and can be used for aerobraking maneuvers by spacecraft. The thin atmosphere is responsible for the surreal appearance of the Martian landscape due to the strange color of the sky. It is incapable of retaining blue and violet solar radiation, which makes Earth's sky blue. Additionally, frequent and violent dust storms leave a large amount of dust suspended, coloring the sky pink. Besides being thin, the atmosphere is also very shallow, only a few kilometers thick. Among the most curious discoveries, which long made people think of finding traces of life, is something related to the red color of the planet due to the layer of dust covering its surface, permeating the atmosphere and tinting the sky orange. The dust consists of various types of hematite, a red or orange iron oxide similar to rust. This mineral typically forms in water and has been found in abundance in the region of Mars called Meridiani Planum. In 2004, the rover Opportunity landed in that area to investigate, based on the assumption that if there was once abundant water, then perhaps traces of Martian life remained. Opportunity found areas covered with small spheres made of a type of hematite that forms in water and is less red than usual. When the photos taken by the rover were manipulated to highlight the spheres, the less red hematite turned blue, so the team nicknamed the spheres blueberries. Look at them. It seems impossible that they are just the result of a purely geological process. But speaking of life, there is a significant limitation to its emergence on Mars, represented by the fact that its magnetic field is very weak, almost non-existent. It generally has less than 1% of the strength of Earth's. It is particularly weak above the crust of the northern lowlands of recent formation, and also above large and deep craters and active volcanic areas. It is stronger above the ancient southern highlands, undisturbed by giant meteorite impacts or volcanism. On Earth, the magnetic field is an almost unnoticed presence. Yet the weakness of the magnetic field is why Mars, from a warm and water-rich planet, has transformed into a cold and arid place. Earth's magnetic field mainly derives from an internal dynamo produced by convective motions in the molten iron core. It surrounds Earth and its atmosphere, extending into space even beyond the Moon's orbit, up to 400,000 kilometers high. The volume it encloses is called the magnetosphere, and it is precisely thanks to this structure that the lethal particles emitted by the Sun cannot reach the surface of our planet. Our star is an immense thermonuclear furnace, continuously emitting enormous quantities of charged particles into space, the so-called solar wind. It is also agitated by gigantic explosions during which the solar wind is particularly dense, hot, and fast. After a few days of travel, the solar wind reaches Earth. The impact deforms Earth's magnetic field, confining it to a region called the magnetosphere, which manages to deflect it and keep it away from our planet, making it flow like river water around a bridge pillar. Without this protection, life would disappear in a few weeks. Mars once had a similar magnetosphere generated by a dynamo which magnetized the rocks. We know this because traces of residual magnetism have been found in the planet's oldest rocks. But then the dynamo stopped working. This happened because the convective motions in the molten iron core of Mars ceased. The reason for this interruption is a secret the planet has yet to reveal. Perhaps being very small, the core cooled quickly, becoming first viscous and then solid. Perhaps the internal structure of Mars is different from Earth's, and the mechanism that creates convective motions deep within Earth, whatever it is, does not exist on Mars. Whatever the reason, 4 billion years ago, the disappearance of the magnetic cover opened the doors to the solar wind, which, in addition to sterilizing the planet's surface with its ultraviolet rays and particle radiation, also began to carry away its atmosphere. This task was facilitated by the planet's small size, unable to retain it longer with its mass. There are studies showing that there are precise planetary size limits for supporting life. If planets are too small, gravity is insufficient to retain the more volatile molecules. This could mean that even the presence of an efficient magnetosphere would not have prevented the loss of the atmosphere. So, in the end, with almost all the atmosphere gone, the atmospheric pressure became too low to allow liquid water to exist on the surface. Now, Mars is an arid planet, swept by global dust storms. It is also a frigid world where winter night temperatures can drop to minus 140 degrees Celsius at the poles. It is the red planet we have come to know, a place that only robotic rovers find hospitable. Could there be a possibility of some liquid water pools on the surface? In fact, for there to be liquid water on the planet's surface, atmospheric pressure would need to be much higher than what it is currently measured. An exception could be the Hellas Planidia crater, which, being the largest and deepest crater on Mars, has a slightly higher atmospheric pressure at the bottom than the triple point. So when the temperature exceeds 0 degrees Celsius, it could contain liquid water. So my friends, Over time, if it had been fortunate enough to retain its magnetosphere, perhaps Mars could have hosted life, even alien creatures like those imagined by H.G. Wells. In that case, we might have truly faced a war of the worlds. But it didn't turn out that way. There remains the hope that in very ancient times, during the Noachian period, primitive forms of life developed that today survive in particularly ecological niches. That would indeed be a secret of Mars waiting to be unveiled. But perhaps there is something else that might give us the fortune to discover that Mars once teemed with life, maybe only at the level of unicellular organisms. Meteorites. Because as you know, we now have the certainty that a large number of meteorites found on our planet's soil come from Mars. The history of Martian meteorites has been reconstructed by measuring radioactive elements and their decay products, which remain trapped in the rocks once they have solidified. It has been established that the rocks from Mars were last in a molten state 1.37 billion years ago, a much more recent time compared to most meteorites, which solidified 4 billion years ago or more. It also seems that all Martian meteorites come from a large fragment expelled into space 200 million years ago when an asteroid crashed into Mars. The impact probably also hurled a shower of smaller fragments into space. Perhaps this event caused the grooves radiating from Phobos' nose, or if not this, a similar one. The large fragment moved away from Mars and began orbiting the solar system like an asteroid. A collision with another asteroid 10 million years ago broke it into smaller parts. These fragments scattered in all directions, orbiting in space for another 10 million years, and recently some have fallen to Earth. This story shows that the planets of the solar system, although separated by tens of millions of kilometers, are not entirely isolated from each other. In reality, there are continuous exchanges of material between them. Lunar material falls to Earth in the form of lunar meteorites, and Earth's material is hurled to the Moon. Just as traffic flows both ways between Earth and the Moon, Martian material has fallen to Earth, and Earth's material has surely ended up on Mars. Therefore, a bit of the soil in your garden or the pot on your windowsill, just a bit, comes from Mars. The carrots you eat contain a pinch of the red planet. And just as there is a sprinkling of Martian soil on Earth, so too Earth's soil is found on Mars. Perhaps that soil contained organisms that developed in the favorable terrestrial environment. The most resilient could have survived in space, and the most resilient of all, after hitching an interplanetary ride and falling by chance into hospitable spots on the red planet, could have survived to colonize Mars. And who knows, if one day we find forms of life on Mars, we might discover to our surprise that they came from Earth, and that the Martians are us.